Section 3.2 is properties of parallel lines. So we're still going to be talking about transversals, but now we're in a situation where line L is parallel to line M. In the last section, it really didn't matter about the two lines in my transversal as long as they crossed. So we still have some of the same situations. We still have vertical angles like 1 and 3. We still have a linear pair like 5 and 6 that add up to 180. But now we also have some special cases that we can look at because of the fact that L and M are parallel to each other. So the first one is a postulate. Remember, a postulate is something that we accept as a definition or as a known value that we don't have to prove. So this says same side interior angles postulate. If a transversal intersects two parallel lines, then same side interior angles are supplementary. So the first thing I want you to do is to write this down, draw the diagram, and come on back. Okay, so same side interior. Interior are the angles in between the two parallel lines. So same side means same side of the transversal. So for this one, we're talking about, for example, angles 4 and 8, or angles 3 and 5. So angle 4, the measure of angle 4, plus the measure of angle 8 equals 180 degrees. Same way, the measure of angle 3 plus the measure of angle 5 is 180 degrees. So same side interior angles add up to 180. Okay, this can be seen. Let's look at the first pair, 4 and 8. We know that 4 and 2 are vertical, so they equal each other. We know that 2 and 3 are a linear pair, so they add up to 180. So why do you think 4 and 8 do? Well, since these lines are parallel, we're going to see that 7 and 4 are the same, 3 and 6 are the same, so therefore 3, 6, and 8 are all the same. So anyway, the same side interior angles will add up to our 180. Again, this only works if L and M are parallel. So this is a postulate. We're going to accept it at face value, and you should know that these two angles add up to 180, and these two add up to 180. So now we have a theorem, alternate interior angles. If a transversal intersects two parallel lines, then alternate interior angles are congruent. So again, copy it down, get your diagram. Alternate interior. So again, the 4 interior angles, but now on alternate sides. So 4 and 5. So angle 4 is congruent, angle 5, and 3 and 8. Angle 8 is congruent to angle 3. So this is a theorem that we need, that we're going to work on and do a proof of. So let's take a look at our proof, and then we'll move on to a few more theorems. So proof of theorem 3.1, that alternate interior angles theorem. So given that line L is parallel to line M, this is important for all the theorems we're doing today. L and M, the two lines being cut by our transversal, have to be parallel. We want to prove, and I can do either one. I can either prove that 4 is congruent to 5, or I can prove that 8 is congruent to 3. So we're going to prove that angle 4 is congruent to angle 5. Okay? So number 1, L is parallel to M, given. The second thing I'm going to look at is some pairs of supplemental angles. So I'm going to say that 3 and 4 are supplemental, measure of angle 3 plus the measure of angle 4 equals 180. And that's the definition of supplemental angles. And then I'm going to say that 3 and 5, measure of angle 3 plus measure of angle 5 is 180, and I can do that by the same side interior angle postulate that we just said a minute ago. So I've got two pairs of angles, one a linear pair and one same side interiors that add up to 180. 4. I'm going to set the measure of angle 3 plus the measure of angle 4 equal to the measure of angle 3 plus the measure of angle 5. Take a second and see if you can figure out the reason for that. Okay, that's our transitive property. Next thing I'm going to do, remember what we're trying to get to, that 4 is congruent to 5, so what do you think I should do next? All right, I'm going to say measure of angle 4 equals measure of angle 5, and that's by the subtraction property. Took the measure of angle 3 away from both sides. And the last step is to say that now these two angles are congruent, and that's the definition of congruency. Okay? So there's our proof that alternate interior angles, like 4 and 5, or 3 and 8, we happen to prove 4 and 5, are congruent. Okay, let's look at our next, okay, what I'd like you to do, I'm sorry, I couldn't figure out this slide for a second. So I'd like you to copy this down and try to prove that angle 1 and angle 7 are supplementary. So take a moment, turn off the slide, and see if you can figure that one out. If you can't, we will do it together in class, but give it a shot. And the more of these that you try on your own, the better off you will be. So don't just skip this over and wait for me to do it for you. Look through and see what you can do. Remember, we have some things to use now. We can use that the same side interior angles are supplementary and that alternate interior angles are congruent. We also still have our vertical angles and our linear pairs to use as tools as well. Okay, another theorem, corresponding angles. If a transversal intersects two parallel lines, there's that caveat that the lines have to be parallel again, then corresponding angles are congruent. Now, what is a corresponding angle? So I don't know if I put the definition down or not. Corresponding angles are angles that are in the same position and on the same side of a transversal. Okay, so corresponding. So the same position and the same side. So 1 and 8 are corresponding. 4 and 7 are corresponding. So let's see, angle 1, and since they're corresponding, they're congruent to 8. Angle 4 is congruent to 7, measure of angle 7. See if you can do the ones on the other side. Okay, corresponding angles have to be on the same side. So on the other side, it would be angle 2 is congruent to angle 5, and angle 3 is congruent to angle 6. Those are your 4 pairs of corresponding angles. Our next theorem is the alternate exterior angles. So again, alternate means either side of the transversal. Two parallel lines again. Alternate exterior are congruent. Exterior means outside of the parallel lines. Alternate 1 and 6. Angle 1 is congruent to angle 6. and angle 2 is congruent to angle 7. So you can see we have a ton of different relationships going on here that we can use. And you need to be fairly familiar with all of these. Once you work with them a bit, they will kind of be common sense to you. But that's it for today. Be sure you've attempted that proof on your own. I want to see it, at least an attempt on it, at your notes. And that's it for today.